Hello everyone. I am sad that the Vintage Computer Festival was canceled, but I do hope that you all are doing well. I did want to take advantage of this video opportunity to introduce a system that I used as a really young teenager. What you're looking at here, this is a Signetics Instructor50. It was built in about 1978, 1979 or so, which is about, as best as I can remember, the time that I actually got mine. What it was meant for was introducing you to the Signetics 2650 microprocessor, which I'll tell you about in just a little bit. Over here, this is the actual one that I had when I was younger. I took everything apart because I wanted to see what it was like inside. And so one of the things that you can see from this is out of the back here, this came with an S100 bus. And those solder marks that you see are where I had wired it up to a speaker. By strobing, one of those pins on the S100, you could get it to make tones, and so that was kind of fun. So let's come back to this one. It also had a tape interface, and so you hook it up to your cassette tape to store and retrieve programs, and so you'd plug it in there, get your volume and your tone dial set just right, hopefully on the cassette player, so that you could load your programs and then save them off. That's actually what these buttons are for here. The WCAS and RCAS. That's write cassette and read cassette. And so you'd enter, for like a write, you'd enter what memory addresses you wanted to store and save it off and plug into your cassette tape, and off you would go. This program, came with they call it a monitor program, which is by pressing this Mon key here. It puts you into a very simple little environment that allows you to examine memory, enter values into memory, see the values of registers, and things like that. So what's actually inside of here? There is a Signetics 2650. That processor was introduced in about 1975, so not too far, not too long after the 8080. It can address 32K of memory. This machine here actually came with 640 bytes. Unfortunately, 128 of that are used by this monitor program, and so you are left with a 512 bytes of RAM that you could use. The 2650 has 7 8-bit general purpose addressable registers, and they're kind of funky because only 4 are visible at a time. The way that worked is register 0 is always visible, but the other ones are bank switched, so 1 through 3, depending, you could see those depending on how the bit was set in the program status word. If you wanted to see the other ones, what was that, 4 through 7, you'd have to change the bit in the program status word, and then the other registers would become available to you. So that was kind of interesting. The reset button on here just starts the CPU executing instructions at 0. And then, as you can see, there's also these switches here on the side. You could use these input values. There are also lights up here that you could set. Let me show you that just real quick. This setting here governs where the values are coming from and being sent to. So in this case, FFF will be the memory port that it's reading the light values from. So let's go to memory. Let's go to FFF. Enter next. Sorry for the amateur cameraman. Let's put, I don't know, the value 5 in there. The error 3, what the Instructor50 does is every time it does a write to memory, it validates that the write happened. And in this case it didn't, because we wrote to a port, not to memory. And so it's just complaining, hey, the value you threw in there didn't make it. But on our lights we can see, let me shade this just a touch, you can see that, yeah, there it is, and there's a value of 5 in binary. So let's press monitor to reset that. I've entered a little program into here. It's one that I wrote when I was a kid that just counts as fast as it could go. I wanted to see how fast the computer did, and then I compared it against my Apple II. And a couple of years ago, I wrote the same program in 386 assembly and ran it on a PC just because I wanted to see the comparison. It's kind of amusing. But anyway, so the way that this program was entered is you start out with the memory address you want to put your program in, and then you would just enter the hex codes, right? So this first instruction here is load immediate register 1, and with that value, which is 0. This next instruction is load immediate register 2 the value of f. And so you just enter these, codes. And so I have these pieces of paper with my code on it, and I would write it out in the mnemonics, which are, conveniently provided on top of the Instructor50 here. And then I would go through and convert them to the hex and then, type them in. To this day, and this is a long time later, some of these numbers I still remember, at least the sequences, which I find kind of amusing what your brain can remember. Well, I'd actually like to show you this running a little bit. So let's start this off. So the way you start this running is you set the program counter on the CPU for where you'd like to begin. So register C is the program counter. Let's start it at address 10, and then we'll hit enter. Let's just do a step and see what happens here. So we just stepped over the first instruction, which is, I just talked about was a load immediate to register 1. Let's go see if that actually happened. It's supposed to be a 0 in there. So you press the register button, and then the 1, and sure enough, there it is. So what else can you do here? This thing supported breakpoints, and so let's set a breakpoint for fun. We'll set it location 48, which is the instruction where the hundredths place starts to get incremented. So we'll enter that, and we'll hit run. And it ran briefly, and it incremented the 100, and we've stopped on memory location 48, the little dash. If I remember right, it meant we're in break mode. And then we're on an instruction 9C. What that instruction was branch on condition false absolute. And what it's doing here is it's just deciding whether to keep on going or whether to go back and run up the numbers to 100 again. And so let's clear this breakpoint. So we'll just press it twice, we'll hit enter, and we'll hit run, and we'll let it continue running. I hope that you're doing well during this interesting time, but I am grateful for this opportunity we've had to at least video share, our older computers. Take care. See you later.